Okay, so this is the iGCSE Edexcel 1 to 9 2018 due paper 1 series of exam question walkthroughs. This is the last question, question 12 in the series for this paper, and it's a little bit more tricky. There's lots of concepts they've thrown in which make students sort of think about lots of different ideas, so there's more to it than meets the eye. Same set of equations that you normally get given for paper 1. It's asking us about a steam engine. So it's nice if you've had a look at one before, had a think about one. So we've got pipe from the firebox to the chimney there, so firebox, chimney that's actually horizontal. There's water and steam, so obviously the water's getting hot and it's getting boiled, and then the steam builds up some pressure. We've got inlet valves and outlet valves and pistons that move, that push the wheels, and a cylinder effectively to take the pressure changes. So there's lots going on. Okay, so coal is burned in the firebox to heat up the water in the boiler. Coal is a non-renewable fuel. Give an example of another non-renewable fuel. Well, lots of choice, isn't there? Go for oil, natural gas, petrol, diesel, uranium, plutonium, methane. You don't get any marks if you're not specific. Okay, so fossil fuels is not enough. Nuclear, you need to actually give the fuel itself, so uranium or plutonium, not just saying nuclear. So that's an important point there, isn't it? Now then, tells you actually how the steam engine works. So it's not requiring you to actually have previously thought all about steam engines, although it does help. So it tells you that the hot air from the firebox passes through a pipe to the chimney. Water is heated as the pipe passes through the boiler, and the water boils to form steam, and the steam is trapped by that closed inlet valve and continues to be heated. So we get a pressure increase. So they're asking you actually for a thing out of year 11, which is explaining why the pressure of the steam increases as its temperature increases. So what we're looking for, well, any three from an increase in the average speed, because all the molecules are travelling at different speeds, but they have an average speed which gives them an average kinetic energy, or the particles, due to higher temperatures, and they'd allow for alternatives for particles, like e.g. you could say molecules. Marking point 2 then, the particles collide with the wall more often, or maybe more frequently we could say, and then they have more force, so they will hit harder. That allow then, you could say, for a greater change of momentum instead of force. And then the linking thing for a fourth mark, but clearly you can only get 3, pressure is force on an area. So award only if marking point 2 or 3 have been seen, and they would allow the symbol of the equation pressure is force over area. So if you tackled it in a sort of pressure idea with force and area, you're getting 3 marks, but you do get the mark if you've talked about the average speed and the kinetic energy as well. Now then, when the inlet valve is open, the steam moves into the cylinder, and the steam exerts a force on the piston in the cylinder. State the equation linking pressure is force and area. Well, of course, pressure is force over area. P is capital F over capital A. Now, if the steam has a pressure of 1.4 megapascals, and the piston has an area of 0.0243 meters squared, calculate the force on the piston. Well, let's see. 3 marks, so substitution, rearrangement, evaluation. So I'll put the numbers in. Megapascals over. Now, what have I done here? I've not put the little 6 at the top, that's my mistake, but I should have a 6 for megapascals. I've put it in here. So I rearranged, I had to do the times, so that goes to the side, so it becomes a times, and I get 3.52 times 10 to the 4 newtons. You have to do megapascals. -1 if you do a power of 10 error, so if you don't convert from megapascals to pascals, they would allow 35,235 newtons. But like we said, if you got a power of 10 error, you could get 2 marks for this one because you'd failed to convert properly. Okay. Part D, the force pushes the piston so that the wheels turn and the train moves. The process transfers chemical energy from coal into useful kinetic energy state, a type of energy that is wasted in this process. Not easy. Thermal, sound, heat would all be allowed. Now, a Sankey diagram. Sometimes people find these a bit tricky, but they're not as hard as they look. Okay, so you've got to, using the diagram, and it is drawn to a scale. Now I've changed the scale because I read it off my PowerPoint, but I'm giving you an example. So calculate the efficiency of the steam train. Wow. One marking point would be the efficiency equation seen or implied. Marking point 2, measurement of useful energy output. Marking point 3, measurement of total energy input. And marking point 4, the evaluation. Now, I've measured, and I've got 62 millimetres and 9 millimetres. So the input was 62, and the useful's 9. And the wastage you could also measure as well. So efficiency is useful over total. So I've said 9 millimetres or 0.9 centimetres. They would allow a range of 8 to 10 millimetres. The input 62 mil or 6.2. They will allow 61 to 63. The efficiency then will be 0.15. If I've done the 9 over the 62, they'd allow 0.14 to 0.15 as a range, and would allow if it's given as a percentage as well. And that's it. So that's the whole paper done and dusted.